Hi guys, I'm Danny. This is my cameraman, Brady Mitchell Rogers. I just want to shout out Brady Mitchell Rogers. Thanks for holding my phone.
Of course.
So, task one is to draw a enantiomer. So we're gonna, make our little thing. We're gonna put we'll have this one here be some chloride with a little hydrogen on it. We'll have right here be some. We'll make it that some OH, or no, that can be something. I don't know. We'll let that be bromide. That's a thing that exists. And yeah, we're gonna have some hydrogen on that as well. So the enantiomer of this, since as we all know, it is a mirror image. There can be 0 to 1 of them. So we have, luckily, this is our example, our beautiful example right here, only it's 1. So I'm just gonna draw that. Now when you draw one of these, what you do is since you see how this normally, this is bolded, right, because it's going towards you. But in the mirror image, it's not going towards you. It's going away from you. But the hydrogen that was going away from you is now going towards you. This is bolded, if you can't tell, on the beautiful artistic skills. And then likewise, down here as well. This is going to go away from you. And this is going to go towards you. That's an enantiomer for this specific compound. Now we're going to draw the I have a speech impediment. It's not. Stop laughing, Brady. Anyways, we're drawing that thing that I can't pronounce because, yeah. So that is not a mirror. So this, the the word I can't say is not a mirror image, and there can be 0 to a lot of them. Now,
It's diastereomer, by the way.
okay, shut up, Brady. I'm gonna put marker on your face. Anyways, so I'm gonna draw this now without the rude interruptions of my cameraman. So just draw this the same way for the chloride, but we're going to flip the one down here. Just do my before discuss. And this is a the word my cameraman said rudely that I can't pronounce. And if I were to make a mirror image of this, this would also be one of those for these as well. Now, next part, which is a meso compound. So what a meso compound is, it is one of the, basically, it is a chiral compound that can be superimposed on top of each other. So this means that it is one of those cases where it does not have a enantiomer because the mirror image of itself is just itself, so there's no difference. It does still have the diasterone. I'm gonna stop trying to say the word. I can't say it. I don't want to be real with you. Anyways, that's a meso compound. You know what it is because you superimpose it over itself. It's just itself again. Next problem, which is, I'm just gonna, drawing that thing. Where you do the RS. I'm just gonna see there's no real writing on this, but I just need this so I know how to do it. It says example, not from notes, but that's the writing on that one. So doop, 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 doop. Hi. Anyways, so it says there's only one chiral center. This is very clearly this point right here because this is not tetrahedral. Therefore, cannot be a chiral center. So let's identify whether it's R or S. So we can look at the bonds here. This is just carbon and hydrogen, so that's C to H3. This is just hydrogen. this starts with an oxygen, and then that's bonding to a carbon, and then this bonds is a carbon double bond to the oxygen, which strings.
That's not supposed to. That's supposed to be a line.
Oh, well, shut up, Brady. You know what? It's fine. I drew it in the right order, so it makes sense. Anyways, yeah. So we can use the atomic numbers to identify the order we're supposed to be order present. So hydrogen, lowest 4. Oxygen, highest 1. 2 carbons, that's a tie. What do? Well, since oxygen is a higher atomic number than hydrogen, this gets to be 2, this gets to be 3. Now, so we assign these numbers and it doesn't look right. So we have to fix it. Now, double bonds, this can't really move. So we're gonna have to switch these 3 around. So we're gonna redraw our structure. Now, since the hydrogen is the number 4, we want that in the back. So to put it in the back, we're gonna have to put it up here as we rotate. So that leaves that, because since we're putting the hydrogen in the back now, that's gonna make this this bolded line here, what was the CH3, that's gonna become planar with us. And then our oxygen, which is number 1, our highest priority, that becomes bolded. That means it's towards us. And now now it's in the proper orientation. So this, since it goes circular in a clockwise fashion, should be R, I think. And yeah, I believe that's all I have to do, right? Yeah, that's my thing. Shout out to my cameraman, Brady Mitchell Rogers. And yeah, hit stop recording.